Hi everyone, welcome to the density math video. This video is going to specifically talk about density, but it's also going to kind of introduce how you can use conversion factors to make the scary math a whole lot easier. So to start off, I just wanted to remind you guys where density comes from. We know that the definition of density is how much stuff we can get packed in a certain amount of space. And we can graph this by using the units mass and volume. And that leads us to density because, of course, slope is rise over run. The rise is going to be the mass, the run is the volume, and then our units here in light green are going to be grams per milliliter or grams per centimeter cubed because, of course, milliliters and centimeters cubed are equivalent. So knowing that this is density, we can use this relationship to we can write it different ways, and the different ways that we write it are going to be helpful for us in different ways. So let me scroll down here. So here I just did a quick sketch. I said, okay, the slope, rise over run, 3 over 4. So here I have mystery substance, and its density is 0.75 grams per mil. Now, the meaning of the relationship is in the equality, and that's the first way that I rewrote it here, saying that 0.75 grams of this mystery substance is equal to 1 milliliter of volume of that substance. And because these things are equal to each other, well, now we can use them as conversion factors, and these are what we use to do the math. So my example that I typically give to help make this more clear to students is think about going in miles per hour. So if I'm going 25 miles per hour, we can rewrite that a lot of different ways. This is the way that's most familiar to us, but we could also say I go 25 miles in 1 hour. I can say it takes me 1 hour to go 25 miles. And et cetera, et cetera. So we can use the fractions here, the conversion factors, to help make calculations easier. Even though we know, this is basics, 25 miles an hour, that's what we need to do. The conversion factors just help make the calculations more visual, and you're less likely to make a mistake when you use them. So let's see them in action. Whenever you have a calculation problem, you should be given two of the three variables, and that's because how else would you solve it for your unknown if you didn't have other variables? So d equals m over v. So in this first question here, it wants to know what is the volume. So that's my end goal. That's what I'm looking for. What is my volume? Occupied by 112 grams of tin, which is my mass. Now, in order to answer this question, in order to solve for V or unknown, I need to know what the D is. And here in this table provided, we can see that the density of tin is 7.31 grams per milliliter. So anytime I'm going to use density to do some calculations, I'm going to rewrite it as a conversion factor in that fraction format that we just saw on the previous page. So I'm going to write 7.31 grams for every 1 milliliter. And I know in my head that I can flip this, but just for you guys to, get used to it, I'm going to rewrite it also as 1 milliliter over 7.31 grams. So we can flip this, up and down. It means the same thing. If we truly did the math and divided, they would be equal. They would both equal 1. So it all works out. Excuse me. So let's take a look at this question. All right. We're always going to start with what's given, and we're given 112 grams. Let me get a pen here. So 112 grams of tin, and it wants to know what the volume is. Now I'm going to take a step back here, and we're going to visit some algebra concepts here. If I were to take, let's say units A, and multiply it by another unit A, what would that give me? Hopefully you can say A squared. Okay. If I did A and I multiplied it by B and then I divided it by A, what would that give me? Well, hopefully you recall that something divided by something else is that same something. So A divided by A cancels out, and I'm left with B. So this second concept right here, this is what we want to focus on, because right now I have grams, but I do not want grams. I want volume, which is going to be milliliters. So I'm going to use this conversion factor to do this algebra magic right here and get rid of the units I don't want and end with the units that I do want. So in order to make grams cancel out, those units need to be on the bottom, on the denominator. So if I look at my two options here, I'm obviously going to use this second one because that puts grams on the bottom and allows me to cancel them out. So I have 1 milliliter for every 7.31 grams. And again, I can see my units, my G's. Oops, I erased some stuff. What was that? Oh, it was a G. Grams. Okay, sorry. So I can cancel out those units and I'm left with milliliters, which again, I can confirm, yes, that's what the question wants. So if I take this and I do the math, 112 divided by 7.31, I get 15.32 milliliters. And that's my final answer. So when you listen to it being explained, it sounds like it's super complicated, but it's very, very simple if you just look at it in this algebraic view. You don't have to think about, oh, should I multiply? Oh, should I divide? Let the units do the work for you. And as long as you know how to rewrite these numbers as a fraction, then you'll always have the conversion factor. So let's do one more problem together before I let you guys go off into the world and try this for yourself. So what would actually be really great, go ahead and read this question and then pause the video, try to do the work and get an answer, and then you can play the video and see if you got it right. All right, so hopefully you got your answer. And now we're going to go through this. So again, I'm going to take a look at what was given, 0.36 milliliters. I want to convert that to grams because that's what the question is looking for. So I'm going to write down what I was given, 0.36 milliliters. I know I'm going to need to multiply that by a fraction, right? So in this question, my substance is copper. So in order to do this, I need to know copper's density, which all the way over here is 8.96. So that means 8.96 grams for every 1 milliliter, or 1 milliliter for every 8.96 grams. All right. So I have my conversion factor. All I did was rewrite this number. Now I can't do it. Oops. All I did was take this number, knowing that it's grams per milliliter, and rewrote it as a conversion factor. So now, how am I going to plug this in? Which one am I going to use? Well, I know that, where's my purple? So I know that milliliters is here. So when I put my fraction in, I should have milliliters on the bottom, which is going to give me this one. So I'll put 8.96 grams for every 1 milliliter. Plug that into the calculator. 0.36 times 8.96, yeah. As long as I plug that into the calculator correctly, the answer should be 3.2. It's 2256. I'm just going to do 3.23. And my units, first of all, it's grams, because that's what the question asks, but also milliliters cancels out, and I'm left with grams. So that just helps, confirm what I thought the unit should be. And there you have it. So hopefully you guys now know how to use a conversion factor to do any kind of math that a question might want you to do by simply lining up the units and canceling out the units that you no longer want or need. Thank you guys so much. See you later.